Alright, ladies and gentlemen, today we're going to talk about the rational root theorem and what are rational roots. So a rational root is a very simple idea. It's basically if we solve for x in a polynomial. Once we solve for x, that gives us the rational root. So a root, in essence, is solving for x. Okay? There's other ways to talk about roots. The word root can be interchanged and means the same thing as solution, which means the same thing as zero, which means the same thing as x-intercepts. These all are the same idea. So to find possible or to find rational roots, where in essence we are just solving for x. Okay? So the rational root theorem, which is explained here, is just a way to help us solve for x. So how do we use the rational root theorem? What the rational root theorem does is it gives us a list of all possible answers or roots. So it is just a way to give us a possible answers. It's not going to give us the answer. We actually have to do more work. But it's a way to give us possible answers so we can find all the solutions. To do the rational root, if you look at this here, which I will explain later, we are basically going to divide two numbers. Okay? Or in other words, we're going to divide multiple numbers. So go ahead and read this. It might not make much sense to you, but I'm going to show you how to use this thing so we can start finding all the answers for x. Okay? Alright, so again, as a summary, the rational root theorem is a way to give us possible solutions. Doesn't give us the exact solution, it gives us possible solutions. So keep that in mind. All right. So on your Google Classroom, I want you to give me the factors of b. So in the comments on Google Classroom, go ahead and give me all the factors of b. All right. All right, so let's use the rational root theorem. Okay, we're going to do example D here. The steps are above, as you can see here. So as I go through example D, I'm going to show you how to use the rational root theorem. Keep in mind, our ultimate goal is to solve for x. We want to solve for x eventually. Okay? Right now, we're not really going to solve for x. What we're going to do is find possible answers that x can equal. Okay? So, to use the rational root theorem, the first thing we want to do is list all the factors of the leading coefficient and the constant of the given polynomial. So as a reminder, in step 1 here, we want to list, here's the leading coefficient, we want to list all their factors, and then here's the constant. We want to list all the factors. So let's do that now. This is step 1. So as you can see, the factors of 3 are positive and negative 1 and 3. So again, remember, factors are things that multiply to give you this number. The factors are 10 are all the positive and negative numbers that multiply to 10. And here's the list. So that is step 1. Okay, so now that we have the factors of the constant and the factors of the leading coefficient, Step 2 says write all the factors of the constant over each factor of the leading coefficient. Okay, to do this, I'm going to reorganize really quick, and this is what it should look like. So step 2 looks something like this, but we're not completely done with step 2. Notice I did all the constant factors, and I'm going to divide them by all the leading coefficient factors. And what we're going to do is we are going to create a list of numbers using one number from the top, the constant factors, and we're going to divide it by one number from the bottom. And this list we create are all possible roots. So bear with me. Okay, so we're going to do this systematically. We're going to take the 1 divided by this one. 1 divided by 1 is 1. Okay, now we're going to take the 1 and divide it by the next bottom number. 1 divided by 3 is 1/3. So that's our next possible solution. So we're done with the ones. It divided by both of these. So we move on to the next number. 2 divided by 1 is 2. 2 divided by 3 is 2/3. 2 has been divided by all these numbers. We move on to 5. 5 divided by 1 is 5. And 5 divided by 3 is 5/3. So 5 has been divided by both bottom numbers. So we do 10. 10 divided by 1 is 10. And then 10 divided by 3 is 10/3. Okay, keep in mind we're going to put a plus minus here because these are both positive and negative possible roots. So this is using rational root theorem. So this list of numbers are possible answers for x. They're not all answers. Only a few might work. One might work. None might work. They are just possible answers. So we are done using the rational root theorem. As you can see, we do have more steps up here, but these steps are when we actually try to solve for x. Well, we're trying to complete the whole thing. Right now, we're just practicing getting possible answers. Okay, so let's do example E. So in example E, our factors of the constant, we're going to use 27, ignoring the sign. We just want to use 27 and write all the factors here. And then our leading coefficient here is actually 1. So we're going to write all the leading coefficient factors here. So here we have the factors of the constant. Constant is the guy without the variable. It's these 4. And now I'm going to list the factors of the leading coefficient, which is simple because it's only plus or minus 1. Now from this list here, I'm going to create a new list where I take the top number divided by the bottom number, and this will be my possible solutions. So 1 divided by 1, that gives me 1. 1, there's nothing else to divide, so we're done with the top 1. So now we go here, 27 divided by 1, that's 27, nothing else to do. Then we go 3 divided by 1, 3, and then 9 divided by 1, 9. Always remember, it's plus minus. These are all the possible solutions. Again, this is how we do rational root theorem. So go ahead and find the possible solutions for F and G for extra practice.
Have you tasted like the, what's it called? The sandwiches? The vanilla cookie sandwiches?
Alright guys, we're going to do example H, and in example H, we're actually going to use all these steps here. The previous examples, we only did up to step 2. Okay, so in this example here, we're going to do all the way up to step 4. So, our goal here in example H is to find all the roots. And like I mentioned before, our goal is to solve for x. That's the same as finding all the roots. So to do this, the fastest way to solve for x would be to factor. But as you notice, this problem that we have, even though it has 4 terms, factor by grouping will not work. You can try it, but don't waste your time. It's not going to work. So this is when factoring does not work, we use the rational root theorem. So when factoring doesn't work, we use rational root theorem, RRT. So let's do it. So step 1, we're going to list all the factors just like we did in the previous examples, and our goal is to find all the possible solutions. Okay, so now that we have all the factors from our constant, which I have above, and our leading coefficient, which I have below, I'm now going to create the list of all possible solutions by taking the top, dividing by the bottom, just like we did in the last example. So we're going to have plus or minus 1 divided by 1. 1 is a possible root. 2 divided by 1. 2 is a possible root. 4 divided by 1. 4 is a possible root or solution. 5 divided by 1. 5, and so on. 10 divided by 1. 20 divided by 1. So again, these are possible solutions. Now my job, so step 2 is done. Now my job is to jump to step 3. We're going to use synthetic division to see which one of these guys here actually is a solution. So to use synthetic division, in order for it to be a solution, we have this idea. Synthetic division will give us a solution if and only if we have a remainder of 0. Once we get a remainder of 0, that's when we know we have a solution. So let's set it up. We're going to first try 1 as our possible solution. So let's set this problem up for synthetic division. So we're going to take our leading coefficients here, make sure we're not skipping, make sure it's in standard form. So it's going to be 1, 1, 2, negative 19, and negative 20. Put my line just like we did before, and we have our box. We're going to start off with positive 1. If positive 1 doesn't work, then we'll try negative 1. So positive 1 is going to go here. We're not switching signs because it's not in polynomial form. Just put positive 1 here. And let's try this. Bring down the 1. 1 times 1 is 1. 2 times 1 is 2. 1 times 2 is 2. Negative 19 and 2, that's negative 17. 1 times negative 17 is negative 17. And we have a negative 37 remainder. So we now know positive 1 is not a solution because our remainder is not 0. So now we're going to try negative 1. And we're going to do this process until we get a remainder of 0. So let's set it up for negative 1. So now we're set up for negative 1. And we're going to do this process. And our hope is we get a remainder of 0. bring down the 1. That's negative 1. That gives me 1. That gives me negative 1 times 1 is negative 1. That gives me negative 20. Negative 1 times negative 20 is positive 20. And there we go. We get a remainder of 0. Therefore, 1 is a solution, or in other words, it's a root. So we have found x equals to negative 1 is one of our answers. Okay? So now we have to find more answers because we still have this polynomial here. So we are going to rewrite this. Okay? And if you look at step 4 here, based on our results from step 3, so our answer down here, we want to see if we can factor our answer, and if we can find roots that way. If we cannot factor it, we would have to start step 3 all over again. Okay, so let's try and see if we could rewrite this polynomial here. We've practiced this before, so we're going to rewrite this and see if we can factor. So we're going to rewrite this. Remember, in order to write this as a polynomial, we take one less power than our original problem up here. So it was a power of 3. So since it was a power of 3 up here, that means when I write this, it's going to be a power of 2. So it's going to be 1x squared plus, and then we go down a power, 1x minus 20. So now looking at this problem, which we got from our synthetic division, I want to see what method I can use to factor this. Since it's a trinomial with that pattern, I can try diamond method. So let's try diamond method. And diamond method would look like this. So we're going to put negative 20 on top, positive 1 on the bottom, and the magic pair that goes in here is going to be positive 5 and negative 4. So it is factorable. So now I'm going to factor, okay? X squared plus 5x minus 4x minus 20. We split the b here, and then we're going to factor by grouping. So I'm going to group these two and group these two. My GCF for this guy is going to be x. So we got x plus 5. My GCF here is going to be negative 4. So that's going to be negative 4, and that gives me x plus 5. Since these match, factor by grouping works. So my new factored form is x plus 5. Okay, that's taking these two and writing them down once, and then x minus 4 goes in its own. Okay, so now we have to remember something from IM2. Let me rewrite this up here. So we have x plus 5, x minus 4, and in IM2, in order to solve this, if you recall, we would put them equal to 0. So we put them equal to 0, and that means we could put each of these individual guys equal to 0. X plus 5 is equal to 0. X minus 4 is equal to 0. And now we can solve for x for each of these. So if I solve for x here, subtract 5 from both sides. X equals negative 5. We found a second solution. Add 4 here. X is equal to 4. And then if you recall, we still have our original solution, negative 1. So I'm going to put that here because it's an answer. X equals to negative 1. We have just found every single root. How do I know there's only 3 answers? Because your answers will match your original degree, your highest degree in your problem. So I have 3 answers because I have a third degree polynomial.